Okay,
Yeah.
but I'm just gonna ask him because I will be
Hi, Dom.
Hello.
Hi,
Hey,
Dom.
can you guys
Can
hear
you
me?
hear me? Yeah. Now you are live.
But we cannot hear the volume, right?
Yeah, probably.
You can't hear me? How about now?
Can you present yourself? Getting the
Yeah.
present.
Uh,
Like share screen.
yeah, working
This
on it.
is the second one of the lag. Take time to know
You're presenting YouTube on derived by but
We are not able to hear the volume, the YouTube volume.
uh, laptop is connected. This laptop,
Yeah,
right?
right.
So this laptop should feed
The volume.
sound. No, it's not because the mic is the one volume the sound.
Okay.
So if you put the mic here and then it will feed into the side. That's what
Can you guys hear me? Matt can.
नहीं ये इसके
Hi, Dom. Hello.
Hey,
Hi.
can you hear me?
Yes, I can hear you. Can we do quick testing?
Testing 1, 2, 3.
Someone's coming back. Wait. There's another guy.
Everything good?
मेरा कुछ तो लग रहा अच्छा मैं समझ गया मेरे को लग रहा है ना मेरे मेरे स्पीकर
थोड़ा डाउन है
यूट्यूब के आजकल यूट्यूब के बाद
यूट्यूब पे या फिर
नहीं दिस इज यूट्यूब राइट यहाँ दिक्कत है नाउ कैन यू हियर मी Dom?
I still can hear you.
Yes, now I think we are good. And,
Just let me know when you guys want to kick it off.
along with in-depth deep insights into the technical architecture of their implementations. Our lineup today features industry
Awesome. Thanks, guys. So pleasure to meet everybody. Appreciate you coming out today. I am Dom. I'm the founder of Harpoon. We're going to go through a couple quick slides. Which apologies, that's probably the boring part. And then we'll hop into a demo, which is the part that everybody likes anyway. So Harpoon is a no-code Kubernetes tool. So effectively, we enable drag and drop for Kubernetes, and we dynamically generate all of the configuration and the deployment scripts you need to be successful.
systems suppose and all.
Dom, you can start.
Okay, you can hear me all right?
Yes, that's perfect.
Okay. Let's see. Cool. Thanks everyone for coming today. I'm Dom. I'm the founder of Harpoon. Harpoon is, simply put, a no-code or drag-and-drop Kubernetes platform. What we find is many companies struggle on their digital transformation journey, building out production environments using DevOps. And that seems to be the case all the way down to bootstrap startups. And so also identifying and hiring talent and building pipelines and maintaining cloud infrastructure is complex, cumbersome, and often costly. So Harpoon enables teams of SREs, DevOps engineers, software developers, the ability to dynamically build one-click production environments, build drag and drop deployment pipelines, and deploy software and configure it all with no code. The product itself is really just Kubernetes, but it's visual and easy to use. And you can use different constraints, which we'll get into in a bit in the demo, but we can search for software and drag and drop it, and then just one-click build and deploy it inside the tool. And it works with any Kubernetes distribution and any software dynamically, unlike some of the previous tools that are, lists of products that people have built deployment charts and things for. So some of our target customers are startups that need to get started and get their MVP out to market, so that they can do their demos and find product market fit. But also, enterprises who are, inefficiently managing cloud infrastructure, Kubernetes, specialized skills and years of training previously. So here's just a real quick look of features. I'm not going to sit here and say every one of them, but it's a growing list all the time. And it encompasses a lot of the things you can do with Kubernetes just visually. And now we're going to get into the real part where people actually enjoy, where we do the demo. So I'm going to pass it off to Matt.
Tom, are you able to hear me?
Yeah, you guys have to add Matt to the stage.
Oh, one minute. Sorry for this glitch because I think, is there any YouTube stream opened at your end?
Not on my end, no.
Okay. Okay. Can you present your screen right now?
I'm not doing the demo. Like Matt's doing the demo, so you have to add him to the stage.
Can you start up again, because that voice was echoing when you were presenting the slide. So you have to start it over again one more time.
Start over with the slides.
Yes, yes. So can you present your screen with the slides?
Good.
All right. Okay. I'll remove myself from the stream.
Good to go. Good to start, Karan. I can't hear you guys on this end, so.
Dom, you can start.
Okay, yeah, I would maybe leave yourself on the screen, Karan, because I can't hear anybody otherwise.
Okay.
Cool. Thanks for coming, guys. I'll get through some slides really quickly, and then we can hop into a demo. I'm Dom, the founder of Harpoon. Harpoon is a no-code drag-and-drop Kubernetes platform, and effectively we make it super easy for developers, SREs, and DevOps engineers to instantly deploy production environments, staging environments, and deploy and configure software all visually with Kubernetes. So Harpoon itself is Kubernetes, but it's visual and easy to use. You can search for any software, you can drag and drop it onto the screen, and you can configure it visually and build and deploy it just with a few button clicks. And it works with any Kubernetes distribution and any versus a set list of tools that you can click a button for. We're working with a lot of startups and also enterprises when it comes to making Kubernetes easier to use and maintain. And we're enabling a lot of development and ops resources to utilize Kubernetes without a lot of specialized training and capabilities to really increase efficiencies of existing DevOps teams and enable developers themselves to have developer self-service for DevOps, which was previously unheard of. So here's a real quick look at the current features that we have. And then we'll get into a demo in just a second with Matt to walk through them visually.
This will be.
Yeah. Let's see if the volume goes, because if this is the laptop, the volume should go. It should come back up.
Can you swap back to the stage, Karan?
Hello.
Yeah, there you go.
Now it's
So I'm just going to jump right into the demo. Harpoon it's a pretty simple UI. I'm going to cover three things. I wasn't muted. Basically, how to start a cluster, how to deploy images, and how to actually configure those deployments. So getting a cluster started in Harpoon is super easy. It's as simple as linking an account in this top right. So I have linked my Azure account. This is going to start up an AKS cluster once I hit this start cluster button top left.
We cannot see your screen, Matthew. Can you
can see
present?
it all?
Yeah, can you share the screen again?
Yep.
Present.
What about now?
Yeah, now I can see it.
Yep.
And yes, that's good.
Okay, sweet. So right when you log into Harpoon, you're basically going to be listed with all your projects, and you would click into a project to actually go and start a cluster. I'm going to cover starting a cluster, deploying an image, and configuring images. Starting a cluster in Harpoon takes around 5 to 7 minutes, depending on what Kubernetes distribution you're using. So I've already started this cluster. That's why this node is glowing blue. But to start this cluster, all I did was link my Azure account and then click the Start Cluster button, top left. This is going to run the same Terraform every single time, stand up the same AKS cluster, EKS cluster, GKE cluster every single time. I already started the cluster before the demo because it takes around 5 to 7 minutes, and I didn't want to sit here watching the cluster stand up. So there's some features when starting a cloud, when starting a cluster that Harpoon basically gives you the opportunity to do, and that's start the cluster on a different region, start the cluster with a default VM size if you need a little bigger for workloads, and then whitelisting IPs to actually give access into the cluster. So all I had to do was link my account top left and then click the Start Cluster button. Terraform runs, and this node glows blue when the cluster is fully up. So I'm going to go to this left-hand side. This is basically where you would get all of your images to deploy to the cluster you just stood up. I'm going to drag out Mongo, and I'm going to drag out Harpoon Demo. Simple images, good for demoing. We support Docker Hub, any public images, GitHub repositories, so you can drag and drop any GitHub repo you have, Harbor images, and the Harpoon container registry that I'll get to a little bit later. But it's as simple as dragging out an image and clicking deploy. This is going to create a deployment for that image in the cluster you just stood up. So in around 10 minutes, you could have a cluster stood up and images deployed. And once these deployments go blue, you know they're running. So Harpoon does kind of like a color scheme, transparent, nothing's happening, yellow, it's deploying, blue, it's running. And just to show you that it's not just magic in a box, you can grab logs from these deployments by just clicking on this log button. These are going to spit out those Mongo logs for the Mongo container, and the Harpoon demo, same thing. Just shows you that it's actually not magic. And we also show you the deployment YAML that we generate every time. So if you're more of a DevOps guy and you actually want custom configurations, you can actually come in here and edit this YAML with anything you'd like. And I'll probably move on to configuration now. So the top left was the cluster controller. The left-hand side is kind of where you get your images. And then this right-hand side is all more Kubernetes-esque elements. Config maps, volumes or PVCs, secrets, and ingress routes are all elements inside of Kubernetes that allow you to configure your deployments. So a config map would just inject environment variables. I'm just doing dummy injections into Mongo. And you can actually see the deployment YAML update with that config map inside of it. So you know the environment variables are getting injected. And Mongo is a database. So I'm going to attach a PVC, a persistent volume claim. This is basically just for any database you would probably want a PVC attached. So if anything happened to Mongo, you could just drag out another Mongo, attach to the same PVC, and your data is still there. Mongo mounts a data DB, I think, but I'll go with data. This ingress route is basically what opens any deployment to the outside world. So I'm going to open up port 80, hit save. This is going to create an ingress route in Kubernetes, so I can actually show you the UI of Harpoon demo. And secrets are just encrypted config maps, same thing, just injecting environment variables. I'll do that just for fun. So you can see that after everything deploys, it goes blue. So we know everything deployed successfully. I can actually go and access this Harpoon demo deployment in a browser just by popping out the ingress route. Azure takes a little bit for the IP to resolve, but we will see a front end here soon if it allows me. Come on, buddy. We can come back to it, but it will be there. So the right-hand side was the more Kubernetes-esque elements. Oh, I thought it resolved. And basically the buttons at the top of the deployments are more configuration options. So you can get pod information, deployment YAML, deployment commands, internal ports for pod-to-pod communication, logs. So I'll cover auto deployments next. Harpoon actually integrates with CI/CD pipelines. It's a relatively new feature we added. Makes it pretty easy for developers to actually integrate with Harpoon. All you do is come to the developer settings, generate an API token, and you can actually just put all these steps in your Git runner, however you do CI/CD. Travis, you just add these steps to your deployment pipeline. When the image actually gets pushed to the Harpoon registry, we recognize it and auto deploy, for example, Harpoon demo. So this makes it very easy for dev to staging to prod pipelines, not actually having to come in and change your version number. You can just add these steps to your Git pipeline. Once that image gets pushed, Harpoon recognizes it, auto deploys Harpoon demo to the latest. So that's a nice feature, and that's actually how you search for these images on this left-hand side, is basically just pushing images to your container registry through Harpoon. You can search for them on this left-hand side, drag and drop them out. I'll cover internal ports. So for Mongo to be able to communicate with any other pods inside the cluster, you're going to need to open up a port on it. So I'm going to open up 27017 on Mongo and grab the pod information. And this service name can actually be used in any, so let's say we have an Express server and we need Express server to communicate with Mongo. We'd actually use this internal service name in the actual source code to get those two pods to communicate within the cluster. Deployment YAML commands, internal port logs. So that's kind of like the most high level overview of Harpoon. I'm going to go to a demo that I already did beforehand because these images take a while to build. But this is a merge stack. So this is a React front end, a Express backend, and a Mongo database, all deployed in Harpoon. It's more of a production like example of a deployment. So as you can see, we have a nice little Harpoon Valentine's Day invite list. You can create records, mat, relation, doesn't matter. And it basically just shows you a more realistic deployment. So here it was an HTML front end and it has to be resolved by now. Yeah. So super simple HTML front end, not really that fancy. So we have more of a merge stack demo that's better to demo. So that's front end in React, a back end in Express, and a Mongo pod to hold the list of users. You can see I have internal ports open on Mongo and Harpoon demo back, and I'm actually configuring this Express server with that internal service name. So that's how you do that pod to pod communication inside the cluster. And besides that, I think it's pretty There's like a lot of more like typical features, like organizations. If you have a company where you have multiple developers working on the same project, we allow for organizations. You can invite multiple users to actually work on the same project, and you can have multiple orgs you're owned to. So it's basically just RBAC, admins, contributors, viewers. Obviously, each of those permissions are going to be limited to certain things. Admins can only create clusters, scale up clusters, scale down clusters. Basically, all the cluster actions are for the admins. Contributors can just do simple deployments, and viewers can check logs, states of deployments. They can't really do much. I think that should be pretty good. Thank you for your time. Appreciate it.
Thanks. Thanks. Hello. Yeah. Thanks. Thanks, Matt. Thanks, Tom. So anybody who are deploying like kind of infrastructure automated deployments can ask questions to Matt or Tom, because it differs from Terraform. You don't need to code anything. You just need to drag and drop your resources, and it's very efficient for Kubernetes and its services. So anybody has a question? Oh, yeah. We have one question.
Okay.
Green light. Push.
Hey, Matt, thanks for the presentation. I just want to know, like, in Terraform, we have the state file and everything, right? So let's say, like, if the resources gets deleted or something, like, how is it going to work in this case?
So he is saying that in Terraform we have the state file. So how it works in Harpoon?
Yep. So I can actually, let me share screen again. That's something I forgot to show. Can you see my screen again?
Not yet.
Not yet. Just a minute.
I'll do it again because it didn't work last time. What about now?
Yeah.
Okay. So yeah, Terraform state files are extremely important, but like the great thing about Harpoon is you're not actually managing the Terraform at all. So when you click this start cluster button, Harpoon's running the Terraform, saving the Terraform state in S3 bucket for EKS. Like it depends on what cloud provider you're using, obviously for the state configuration, but you don't really have to worry about it because Harpoon manages all of that for you. So when you link an account and click start cluster, we run the Terraform, hold the Terraform state, and
That's fine, but what if somebody deletes that instance wrongly? But
if someone goes into your Azure account and deletes, the Harpoon generated.
How do you import it? Or how do you reprovision in this case? Because Harpoon thinks it's already right, but it's not.
Yeah, so I would probably have to. Luckily, we've never actually ran into that, but I'm sure that would be put onto my plate, and we would probably just work with you to.
Because it's not only day 0; you have to think about day 2 or day 1 as well.
And the thing is I hold the Terraform state in my database, so I still have it. Even if you delete, let's say, the S3 bucket that's holding it in AWS, I still have it in my database, so I can recover it for you, basically. But it would be bad. It's not recommended to delete S3 buckets.
But it is possible, right?
Yeah, it's possible. I have a copy, luckily, on my end.
Thanks.
Thank you. Thanks, Satish. Anybody has a question? One more question.
I have a question. If you, let's say you roll out some change and you want to roll it back, is there a typical way to hand that in Harpoon? Oh, another question is, actually, what do those little links mean between the different boxes? Actually, wasn't sure. Were those config maps or?
Can you guys see my screen?
Just
Nope.
It works like the second time every time. Oh, there it is. You see it now?
Yeah.
So for the first question on basically versioning, I guess Harpoon demos are bad. Do any of these have more? Yeah, so that's basically the versioning. Rolling back is with these versioning drop downs. So let's say we know commit BDE is a bad one. After we deployed, everything broke. We could just go back to our latest commit. With the Harpoon demo, like Harpoon feature, it's a lot easier. If I had more versions here listed, it would basically be clicking on the latest version, clicking deploy, and you're rolling back that deployment with 2 clicks. The links, oh, go ahead.
On that front, we also have like auto linkage into CI/CD pipelines. So if you want to merge something and it fails, if you have there's this concept in Kubernetes called replicas, and you can increase the replica count in Harpoon on any resource that you want. Right next to the deploy button is that like little plus and minus. And so if you have multiple replicas for a pod, then and you're trying to either auto deploy or deploy manually a different version of the pod, then Kubernetes itself will like see that it fails, and it will basically do a blue-green deployment and kick it back and only host the version that's working. So it has kind of blue-green deployments built into it automatically. Sorry, go ahead, Matt.
Yeah, no, that's actually perfect. So we do have a concept of orange. A lot of people don't see it in their actual Harpoon UIs, but if your pod ever got into an orange state, it's basically the in-between between yellow and blue. So you have one pod running and one failing. So you would that would tick you off and say, oh, okay, Harpoon's keeping my old deployment alive because the newest deployment's failing, and then you can kind of go and look for it. The connections, the question on these connections on the graph, it's basically like a visual representation of this PVC is owned by this deployment. So it's more of a visual thing than anything else. There's no explicit like reasoning for the linkage besides Harpoon demo has this ingress route open on port 8.
So it's like a ownership hierarchy?
Yeah. And node pools is coming out, which will kind of help this graph a little bit because it kind of gets conjumbled. So we've isolated basically into node pools, so you can kind of isolate deployments into each node pool for heavy workloads, low workloads, things like that.
Cool, thank you.
Yep, thanks for your question.
Thanks, guys. We're gonna take a last question if you have. Yeah, there's one last question.
This is just a more basic question. So this is Harpoon is used as like in like a SaaS kind of mode, is it, or you can deploy it within your own environment, etc.
I can take this one. It is multi-tenant SaaS. That's correct. We do have a deploy your own, but only as like an enterprise license type capability, not necessarily in the lower tiers.
So if somebody's using it as a SaaS, what kind of information or configuration they need to provide to Harpoon? Their like AWS keys or like a cloud keys?
Yeah, you'd have to integrate a cloud service provider account that you have. And then if you whatever software repositories that you want to add for drag and drop, you can also just push containers directly, but whatever you want to drag and drop and deploy to effectively needs to be connected to the account.
I'm just wondering, did you face any challenges like from your clients or companies who are using it, like they need to provide all this information to you?
Not generally. Like a few out of tens of thousands have said I don't want to give that to you guys. But generally, people are looking for efficiency. The like you're generally connecting a lot of these things together anyway. Whether you're using Harpoon or not, like you're pushing deployments through GitHub Actions and things like that. And then nobody ever asked if they can trust Microsoft or whatever, but Microsoft has a lot more security breaches than we do. So, uh, but yeah, like everything's super encrypted. We actually have a bunch of people who have built out the platform who've worked for the U.S. Department of Defense as well. So we're no strangers to security. And actually, the U.S. Navy has a deployment of this already deployed in their infrastructure. So.
Cool. Thank you.
Thank you. Thanks, Tom. Thanks, Matt, for just giving so much deep insights on Harpoon. And it is a powerful tool because you're going to integrate a lot of other services with it. And it will be seamless to deploy and like kind of in a graphical representation, you can have that working together. So thanks, guys. Thanks for being with us. Thank you.
Thanks, guys.
Guys, good night.
Guys, very sorry because our pizza got late, so it just got delivered. So you guys can step out and just come back in the next like 10 minutes, and then we're gonna start the next session. Sorry for that.
So our next speaker is Karan Singh, CEO of Kubetools.io, with over 10 years of experience in MLOps, AI, and cloud-native technologies. Karan had led the development of scalable systems across various environments, including cloud, edge, and hybrid cloud. Today, he will share the latest advancements in Kubetools recommendation service, including new integrations with Harpoon and Docker extensions for an optimized deployment experience. Please welcome Karan.
Hello, hope I'm audible, guys. Thank you. Thank you for joining and thank you for supporting the community work. Uh, so, before I start, I want to introduce my team. He's man. He has been developing Docker extension heavily on Docker desktop, and he has fixed a lot of issues as well. He's Abhijit. He has developed the whole modular framework for KRS and contributed well in this project. So me and Abhijit started coding together, and we started laying out our this idea on the ground. And Muskan, she's supporting us in all these contributions over like open source and how to build the community. Thank you guys. Thank you for your support. Thank you. So so today, you guys have listened to Dom and you have seen like how you can deploy things. But how after the deployment, what happens? You need to maintain those infrastructures or services, right? So here we are. I'm trying to just connect the stories with KRS, which is a Kubetools recommendation service. For me, like I have worked in some companies and I'm contributing towards the community. And today's agenda, I'm gonna talk about like what is the tool complexity problems. Like there are a hell lot of tools right now in Kubernetes, and it makes a difficult choice for a DevOps engineer or SRE engineer to try to figure out what exactly is going to use it for their specialized or for their application and their system maintenance. So how the KRS, like what we have developed, can solve this problem, and how it works. Developed a Docker extension, which will give you a little sense of a UI, because right before that, it's just the CLI interactions. And then I'm going to go and dive into the demo and just going to speak on what's coming next. So as you can see right now that this is a cool CNCF landscape, and there's a hell of a lot of tools and services which has been into various different categories, and it's so difficult that it has become a hellscape right now. So we are just putting a small, we're just calibrating a small part of that ecosystem, which is related to Kubernetes. And if I can tell you, it's around like 600-700 tools around. Some are getting used, some are not getting used, some are not getting maintained, and that's a problem. What we figure out when we do community events. We do this events back in India, trying to do it in Singapore, and we're bringing in the flavor in here. So DevOps engineers are spending time in analyzing and trying to find out the right set of tools for decoupling the services from the Kubernetes. So people develop tools, they're getting maintained. Some tools are getting well maintained. So we are trying to understand how these things can be fixed. And the thing is like just trying to give an edge to all the DevOps, SRE engineers to understand their cluster and scan their clusters. So this is a kind of a fun activity we did, like kind of a periodic table. So just laid out the tools according to the names, and it's become it's become too complex. So this is the same with, and then it comes to the Kubernetes recommender system that we are building. So what the problem does this solve? So and how does it solve this? So we have a ranking system which is right in here, which we're gonna develop, which we are developing, and we are actively contributing towards it, which I'm going to discuss in the next slide. Then we're going to scan your clusters, And then we're going to see what is running on your cluster and what we have back in our database, like our ranking database. And then we're going to recommend you what is the best you can use in a specific category. This part is handled, which is one part. Then it goes to the next part. And then it comes to how you can interact and troubleshoot your pod level issues with this. Similar like Kubernetes GPT, but it has having some improvements, and we're gonna improve it more because Kubernetes GPT will give you only open API access. We have integrated local Hugging Face models as well, so you can use local models if your system supports more DRAM. You can use more like big Olama models with like millions of parameters. It's up to your system configurations and how big model you can upload. So security-wise, you can use that. Don't need to go to OpenAI. Don't need to give any access to the logs or anything. And then there's a feature which is like kind of export the logs, and you can send it over for review, and then that's a part of kind of a telemetry process. Okay, so this is what we're doing to build up the ranking. So we're getting all the sources from like Stack Overflow, Indeed, Kubernetes, yeah, community groups, and Reddit, and even Cloud Native Foundations, and we're trying to rank those data sets and try to weight those data sets. So and uh, and derive kind of a random number, kind of a ranking, and every category will have like a 1 to 10 or 1 to 20, whatever the ranking is, and that's how we are maintaining it. I'm going to show it in the upcoming slides. And then we're going to maintain the DB, and the DB is going to serve your CLIs, your recommender system, which I'm going to show you, and then you can see it on the website as well. So if you guys have heard of DB engines, which is like ranking your DBs, so similar approaches there. We are ranking the Kubernetes tools and services in a categorized manner. All right, here's the part which I was talking about. Like we have different categories on the left side, and we have the tools on the right side, and we are generating a random score out of how well the tool is being organized, how many PRs are raised, how many issues are getting fixed, how many people are talking about it. So understanding all those data points, we have to come up with we are coming up with this ranking. And we are further fine tuning it because we ultimately have to maintain our GitHub repo where this single source of truth is getting all this, all the tools and the respective categories. So we're further automating it. We need more contributions. If you guys are interested, definitely you can contribute to it as well. So apart from this, we just had we just launched a Docker extension. It's just a month ago, and we have like 3K downloads. You guys can try on local desktops as well. So just need to change your Kubernetes context, and whether you have been deployed in your Amazon, Google, Azure, or your local Kubernetes context, it's going to connect to that. These are the tested environments and you can see, you can search in the README file. You can also have a blogs on Kubetools.io, and all these platforms are tested. We have two supported models. One is Hugging Face, and one is OpenAI. This is one of the issues which we recently fixed. So the Kubernetes, the KRS system is not able to understand multi-container pods. So now we have pushed in the fix, and now if you have a crashback loop or a failed pod, so it will analyze every container running inside that multi-container pod, and it's gonna give you a key value pair like an output where the container one will have this error messages, or container two will have this error messages, or if you cannot find anything, so whatever is displayed, the bit is data connect the key value pairs. So this has been done, and we have a business incubators which we are working with. Right now, we have TBDC, Brampton Board of Trade, Communitech, which is in Kitchener, and Beehive, which is Brampton and Ocean District. So what we're going to do is we're going to simply install Docker Desktop, install Docker extension, enable like Kubernetes and integrate with the LLMs. And installing the Docker Desktop, everybody knows about it. It's simple, and installing extension you can roll into the marketplace, and you can see. And just you need to enable the Kubernetes context if you are running local Kubernetes clusters using Docker desktops. So that's the feature I guess a few months back, maybe a year back, that got introduced. And I guess let's jump into the demo. Yes, guess I'm not able to run it within the slides because I have embedded the video in the slide, so that it should not take much time. So just let me figure out that one time. Second. You guys able to see? So this is what Tom has showed us before. So we have a Harpoon, and then we are accessing a EKS cluster, which is deployed on your Amazon cloud. And it's simply like people have asked the question, how are we going to connect to it? Simply giving your secrets and trying to deploy it using your regions. And let's start deploying. So the idea behind this is it's a Kubernetes deployment platform. Very good. But what's coming up next is the integrations. How you can integrate with different tools and services and make it a more robust. Either Harpoon integrates KRS, or KRS has some hook that can understand the deployments and further troubleshoot what is being deployed. So here we are just getting the context into our local Docker desktop environment, and we are updating our kubeconfig, which is our EKS cluster. So simply now what we're going to do is we're going to go back to a Docker desktop, and we're going to install our KRS, which is listed in the marketplace. And simply we're going to select the context over here so that it can connect to the specific Amazon EKS cluster. So that's it. So this is the screen where I guess there's a KRS extension, and that is what is called initialize is like simple init, and you're gonna give a context, and then it's gonna understand, okay, I am connected to a Kubernetes cluster, and then the whole things will be highlighted after that. Otherwise, it will be grayed out, and you cannot proceed to any other thing because you're not having any connection. So next thing is I'm just gonna deploy some tools and services like Grafana, QQ, and just populate the cluster so that we can understand the ranking, in a way. So we're running some Helm charts and we're deploying it. Perfect. So now you can see that everything has come online. So now you can play around with all these options. You're gonna make it more robust. You're gonna make it more useful in upcoming versions of Docker Desktop. So now after initialize, you're gonna just go and click on scan and start scanning your cluster, and it's gonna take a few. And then this is the status which you're going to get out of your Kubernetes cluster, which is deployed on Amazon EKS. So you have a category, you have a tool name, you have a rank, you have a category, and you have CNCF status as well. There's a problem with CNCF status. Anybody who want to contribute it, you can contribute it, and otherwise they've already raised an issue. So it's just like how you're gonna scrape the name, and then it's gonna understand, because the naming convention in a CNCF JSON file is a little different from what I am generating out of my database. So that's not a big problem. But yeah, this is what a present cluster a user is running right now. You have a rank 30, and then the same tool is in the cluster management. So you can have one tool in two different categories as well. We are further fine-tuning it to have like a more tailored approach. And then you have Grafana, and then you have a cube. Okay, and next, simply in 2.0, we are doing the same thing, almost like recommend. So this is the recommendation, and according to that, you got a CNCF status. So we're gonna recommend you the rank one, which is in the category. So that's one of the things that gonna give you what is running and what you can run. So this is what this solves some of the problems. If some person is really want to understand their tech stack or really want to see what's new in the market, maybe this tool just gives them a little context about it, and then they can go and search and work on the recommendation. Other things are simply just kubectl commands, just running and displaying. There's not much in that. So the next part is we're gonna jump on to how we're gonna deploy another services to the EKS cluster and see how KRS interacts with that. So we run a Mongo service, a simple Mongo, which is kind of a database connected to your application. Simple in-house application, and then this application and the database has been deployed, and it's gonna run, and it's gonna fail. So we have a database which is up and running, but we have the application which is not able to run. So as Dom and Matt described that, you can check the logs. So here we are checking the Mongo logs. It's all running fine. Nothing big that deal in it. But here we can see that there is some issue. So if you go, we can scroll extra. So we have a missing environmental variables. So this is what the Harpoon gives us when we are looking into this. So now we don't know what to do. Like it can be any error. It's a simple error which I'm showing right now, but it can be any error which people cannot understand or just want to have a context to it. So now when we do KRS health, coming back to the KRS extension. So we're going to start off with like KRS health, and then we're going to select the specific namespace and the specific pod, which is not able to run. And then we're going to say that please understand what is happening. And here we go. So there's an error message of missing variables, and it's getting displayed. So all the error and the failed entries, the CR is going to catch that. And the idea is not to catch the whole log file, just to catch the tailored uh, lines, so that we are not giving enough tokens to the OpenAI models. So you're not using, like, you're not sending all the data. You're just sending what is required to your models, so that they can understand and give you the right answer. And it also saves you money. So here we are, and so now I'm interacting with the output. So where can I add the environmental variables? So you can be more interactive, or if you're good, you can just figure out. It's just the way how you just write your prompts. And I think everybody here is enough is doing enough GPT nowadays, so you're just going to get a manifest. In the future, there are plans to understand the manifest of a pod and then apply the manifest. And that's going to come, and Abhijit is going to discuss a little on the upcoming features. But right now, a person is just getting a recommendation and is applying it on a YAML file, which is, you can edit it directly on a Harpoon, which is a very, very beautiful feature I see. So you don't need to go inside your cluster, just have a UI, open it up, just put in the what is recommended by the KRS, and here you go. Now, here we are. So this application has been deployed, and we're gonna just add an inverse port to it, and then we're gonna do a go command to it, so that we can see that things are running fine. So the idea here is we have a deployment, we have a troubleshooting agent, how we can use it effectively, how we can use other services. Imagine there's one more tool over here, which is monitoring your cost, which can be added as along with the KRS, along with the Harpoon. So everything you will get it connected in a modular way. And now you can see everything looks good. There are no error logs, and now you can just go out of, like, just log out of your system. So coming back to the slides, anybody has any questions? Okay, cool. So here we have a fun. We are into a fun list. Backdrop build. Backdrop build is nothing but a bunch of, like, people, or like a project or open source, or like not open source, coming together and working on something. So there's a list of like 100 people, 100 different projects, then it drills down to 70, 80, 70, 50, and then goes down. So we are there in the V6, and we are the top, among the top 50. And here's what Abhijit can speak about it, like what's coming next, and how we can make a little more interactive Kubernetes interactions.
Thank you, Karan. So, hello everyone, this is Abhijit. If you don't know me already from my previous session, I am also the head of MLOps and Cloud at Binaloop, a startup that is working in automating the procurement workflow using generative AI. So, me and Karan build KRS together, as he mentioned earlier. So as you can see, the reason for this product is the number of hours I've spent debugging Kubernetes myself. So that is why I built this. I don't care about the community. Just kidding. So uh, so the goal of us, what we are trying to do is inherently making life easier and using generative AI as best as possible. So on that note, right now what is happening is we are just using simple regular expressions to understand the logs, extract wherever there are error messages, only use that for the tokens as Karan mentioned, and trying to get the resolution from existing models. Now, if you are an intermediate level coder, and you can do it yourself actually. So why KRS? So we are trying to build KRS into a multi-agentic system that will have its own database. So the first step that we're doing is we're collecting generally occurring error messages, not just for Kubernetes cluster and networking, but also for uh, programming errors, common errors. Let's say we start with Python, and right now we have collected around 5 to 6,000 types of exceptions that generally occur in Python. Because one of the few questions that have come up from the community is that, hey, I understand that KRS can understand pod errors, but can it also debug application errors? Because that is one of the usual cause of downtime whenever we deploy a certain application. So what we did is we went with Python because it's easier to get started with. And what we are building now is a Python database that can also understand error not from just the pods, networking, and Kubernetes, but also from the application perspective. And we are also working with certain startups that are trying to automate the pull request workflow as well, where we could integrate with them, provide resolutions with respect to where exactly in the application the error is happening, and they can automatically fix that in your code base as well. So that is one of the branches that we are trying to explore. The second part is building our own foundation model. So right now we have a database where we have collected more than 12 to 15,000 Kubernetes errors, and we are trying to collect more as we speak. So we are also requesting from the community to actively provide us with their chat sessions that they are using with KRS, and also provide whatever data is possible to actually help us make the database more, I would say, human measured. Like why? Because we don't want to use generative data. We want to use actual data, error logs that are occurring in everyone's day-to-day deployments, and we're trying to create that database into a fine-tuned model that can be deployed locally for sensitive workloads. Because there are few enterprise related users that have come across to us, and they told that, hey, we are not comfortable releasing our Kubernetes deployment information to an open source tool. And so how about KRS work into our own cloud platform, and we can keep it like protect data from it basically. So what we are trying to do is we are creating our own foundation model, which would be between 1 to 2 billion parameter size initially. And that model would actually not only understand the basic errors that we have, but also provide resolutions in terms of how to fix your current workloads. So that is the second one. And the third one, multi-agentic framework. So what we are trying to do is, since we have this data, so we can experiment with two things. One, creating our own foundation model, and two, trying to create our own database that can be accessible using a query. And we can create function calling where a certain so there is a concept called query decomposition. So what happens is, if I ask a particular query, I can ask a large language model to tell that, hey, give me 10 questions or 10 steps so that I can resolve this particular issue. So we do query decomposition, we get subqueries, and then for each subquery, we assign that to a function, and that function can extract particular data from our cluster or from the database that we are creating, which will help us fix all the issues and try to generate the manifest as Karan was mentioning. And the fourth one, support for local AI, similar to like after step two, once we build our own foundation model, we'll be supporting KRS on premises, so on edge devices, on hybrid deployment, as well as in your own cloud internally. So for any sensitive applications or sensitive workloads, private clouds, edge devices, so the KRS would definitely work on that as well, because everything is working locally. There is no need of internet, And we can also provide a sandbox environment where we provide not only the model but also the database containing all the query and the resolution pairs that would be accessible in a retrieval augmented generation framework. So these are few of the avenues that we are trying to go towards. So the only thing that we are waiting for now is to generate enough data so that we can even try our first effort towards creating the foundation model itself. So that is all about the next steps. Any questions? Okay. I'll give it over to Karan.
Thanks, Abhijit. Thanks for the contribution and thanks for explaining it so beautifully. So, guys, you hopefully got the context, and we do events all over India, in Bangalore especially, and we're starting off in Singapore, and there's a second one in Toronto. We try to keep DevOps, MLOps, try to get a connection between your cloud and your Gen AI related sources, so that it'll become a genuine use case. So we are trying to bring up such use cases which is affecting the day-to-day problem statements. Plus, it can be deployed seamlessly using such technologies, cloud and Kubernetes. So here are we, and just follow us and just join our community, and we'll keep rolling. Thank you, guys. Questions, just open, and I'm going to introduce Satish Kumar, and he's a Cube astronaut, and he has been into the community, and recently he went to the KubeCon, and let him share his story about the KubeCon. Let's give him a good round of applause, guys.
The previous slide which you were sharing. Okay. All pictures are there, right?
Okay, sure.
Yeah, so all the public speaking talk just started with this Kubetools 1.0. That was my first talk. I'm here. So yeah, good to see like all the people here. It's been like 4-5 months now, and yeah, thanks to Karan. I was approaching me during like those days to give a public talk. I was not that confident that time, but I think I'm right now. It's good. So yeah, so like last 4 years, I was following KubeCon virtually. And I had an opportunity to go to KubeCon last month to Salt Lake City, Utah. My name is Satish. So I'm a CubeStar, so I've done all the Kubernetes certifications, CKA, CKAD, CKS, KCNA, KCSA. Yeah, there are like a lot more expansions, so it will take time for me to explain each. Right now, I just want to like share my experience, right? So it was a great opportunity to meet like a great people. I met Kelsey Itava, who is a man behind Kubernetes. So I was just following him through GitHub repo for like 8 years back while I was in Singapore. So from there, going and meeting a person and then speaking to him as a one-on-one meeting for like maybe 30 minutes. It's a great thing. And then I met like a lot of good people, like a good minded. They were like very open and then like trying to share their experiences and stuff. Even Argo CD maintenance and stuff, right? So Argo CD, like they have like 25 million seeding right now, but nobody expected that it will grow so big. Even Backstage, so a contributor for Backstage. I met Backstage, one of the Patrick and Benjamin. Those are the main contributors for Backstage from Spotify. So I used to run Backstage for Lambda for 2 years, and I contributed to Istio as well. Ambient Mesh. If you guys don't know about Ambient Mesh, it's a sidecar-less service mesh. You don't need to run any sidecar anymore. So yeah, you can run like a cycleless, and then like it can reduce your workloads, right? In case if you're doing an upgrade, you don't have to like wait for all the rollouts to happen, like because it has to like every application container as an additional container to be coming up, and then it needs resources as well for that. So a lot of beneficial is there. Like if you haven't tried it, go ahead and look for ambient mesh. So and then yeah, so like I try to encourage, right, if you are going for India, the next KubeCon is happening next week in 11th of December and 12th of December. If you can't make it, then give it a shot in KubeCon Europe. What I would suggest is like you try to book it early. So like even if you do virtual, it's just $10. You just get a CNCF coupon as well, like 50% off. So I used to do that. So it's just $10. If you miss it, it will become like $75. And then best time to buy a CNCF certification is just during the Black Friday deals. Just last week, we got like 65% off. I think even now it's there available. Just go and check the CNCF website. You will get maybe like 60% off if you're trying to do a certification. So yeah, it was a good journey. I'm going to KubeCon Europe as well. I already bought the tickets. So yeah, anything if you want to know about it or anything you want to know, I will be here. Yeah, you can follow me or like you can connect with me. Thanks.
Thank you. Thank you, Satish, for sharing your insights. Our next speaker is Vishal Garg, co-founder and CTO of BlueBash.co. BlueBash specializes in high-performance IT solutions and scalable software for industries like healthcare and e-commerce. With a focus on real-time conversational AI, Vishal will share insights for integrating LiveKit with speech-to-speech large language models to build scalable AI systems. Please help me in joining Vishal.
Hello, everyone. So let's start with a quick introduction. So my name is Vishal. So it's been a decade since I'm working in industry, building SaaS platforms in a different industries, experience with multiple languages. Now working on a couple of new technologies. And today we're going to talk about building a scalable real-time conversational AI. So probably everyone have like been using the GPTs. So anyone has used their voice version? Anyone? Right. Okay. So this is what I'll be explaining today, how the fundamentals of conversational AI works and how we have implemented that concepts into the Kickcall.ai, which currently we are working on. Okay, so starting with the basic components of conversational AI. So everyone know about the speech-to-speech, large language models, and the text-to-speech. So I think if everyone is aware of these three, or kind of sense like how these things work. So to give a basic overview of like what exactly happens with these three components, which is very fundamental of any conversational AI. One is a speech to text. So whenever we start talking, for example, with a GPT, so eventually what happens, all of our speech sent to a server through a WebRTC protocol over like it happens on the real time with like packets are like getting encoded with a compression chunking, and it's being sent to the backend server, right? And over there, if you're using LLM, then it's getting processed with the LLM, and after that it comes to the next part, which is a text to speech, where again, whatever the response is being generated by the LLM, it is getting tokenized and converted to a voice, so which we listen further. So it's all happens over the WebRTC and real time. So introducing a live kit, like what it is. So it's basically an open source, which takes a lot of overhead of developing all of the front end components, like how the different devices like browsers, mobile phones gonna connect to a server, and then they're gonna send us a voice, and we're gonna deliver them a voice again. So it is something being handled by the live kit. In our product, like before before we found the live kit, we were actually using the whole own setup of building this WebRTC protocol, handling all of the things by ourselves, but it's kind of getting complicated on our end. So, and deviating us from not working on the real LLM integrations, the AI agents that we wanted to work, but it's more like working on these things, which is kind of in industry from like over a decade and two, right? So so live kit come up with the two versions. One is a cloud one, and one is open source. So they have everything open source, and which gives a lot of flexibility and handles a lot of complexity for us, and we can easily deploy our applications to like different providers through Kubernetes, right? So this is the basic architecture of something I did. Yeah, this is the basic architecture of a live kit. So we have a live kit server who is responsible for managing everything. It's kind of a brain of like what's happening in a conversational AI, like whatever the conversation is going on. So that's a live kit server. One is SDK. So they have like they offer a variety of SDKs in different languages, whether it's a React JS, React Native. So you can use those SDKs to initiate the voice conversation and the connection with the live kit server. And then it comes with the ingress and egress. So these are the two terminologies. I think probably have you heard about the same in Kubernetes. So this is the same fundamentals over here. So it's responsible for like what is being sent and how what is coming into the rooms, right? Whether it's a voice, whether it's a video. And one thing to point out over here, it's not only for the voice, it's for the multimedia as well. You can send the videos, voice, right? So you can create rooms, you can stream. So pretty much live kit is capable of doing what different tools are doing nowadays, for example Zoom, right? So this architecture, right? And the next the new thing that they have introduced, what was not there like a couple of years back, is their AI agents. So they come up with this AI agent framework, which is kind of a way for us building the agents, right? So like how we gonna respond to the conversation, how our agents gonna add into the room as a participant and start talking with the users. So this is the agent frameworks they have. And the CLA is pretty much basic. You can manage their infrastructure and these things, right? Oh, it's kind of messed up, but yeah. To give a context, like this is a client over there. So here it is supposed to be like a browser, mobile devices, like whatever the clients that wanted to connect with, right? So, and over there there's a live kit cloud. So all of those get connected to the live kit cloud, and we don't have to much worry about the implementation of all of those things, right? Then here comes the backend, and which is the agents framework that we are working on majorly, and making sure that how our agents is not just a conversational but actionable as well. So I'll give you a demo on that, like how that is working. And over here, so it's more of the services, the speech to text, text to speech, or the multi-modals as well. So It's all okay. Okay, so I'll skip this screen. So it's basically a agent framework, how it works. So they kind of a concept of a multiple workers. It's kind of a nodes in a Kubernetes, right? And within the workers, you have a multiple agents sitting out there, right? So what happens? So whenever any rooms get created, right, on our agent framework, we get a hook. So we have an ability to add our AI agent into that room, so that it can start talking to the recipient user. So there are like multiple ways how we can use this, and specifically, like we have tried both of them. The end goal was like to do the voice conversation. One is a voice pipeline, and one is a multi-model agent. The multi-model, oh sorry. So OpenAI has launched this multi-models recently, which is capable of taking images, videos, sounds, and everything, and giving you back the response, right? So that is a multi-model. So within this infrastructure, like we have tried at first with a multi-model, right? So instead of taking care of all text to speech or speech to text, the multi-model was handling for us, which is a OpenAI, right? But it is kind of expensive, and it is like not being used much on our application because we are more focusing on the conversations, right? So it's not the case for us where we need to send back the images and the videos to the LLMs. So we switched to the voice pipeline. So what happens, like whenever the voice comes to our room, so in a real time we convert it to the speech to text, and after that we do the LLM processing, and after that we do the text to speech, right? Okay, so within this LLM processing, what exactly we are doing? So we are not just using the GPT behind, but we have a kind of system where we implement a RAG. Anyone know about, or I think anyone know about the RAG, how it works? A little bit, right? So the RAG is basically a way of using your own knowledge base or documents or any kind of information that you wanted to give to the GPT or any kind of LLM, so that they can work on that particular piece of knowledge to give you the response, right? Because these models are like trained on a very huge data, and if you ask something, they're gonna give you very generic answers or probably the information that have, right? But the RAG is way you can actually complement your own knowledge and give instructions to the LLM in a system prompt that you need to answer within this context, within this information, right? So we can kind of restrict LLM to work with that only piece of information. If you take an example of a small businesses, right, or any business, right, who wanted to have this voice conversation over the phone or over the website, right? So probably they wanted to limit this conversation to their business only, right? So they don't want to have anyone asking on their website or on telephone like, what is a World War I, right? Which is kind of gonna be funny if it start replying that. So eventually, like what we are using a voice pipeline for our application because it's the most suited, and it's a cost effective as well. So I'm gonna show you the quick working of it. Oh, it's already opened.
This is one of the agents which we deployed on Kubetools.io, our website, which supports the Kubernetes related queries. So Vishal and Anuj helped me to deploy this conversational bot so that it will be supercharged with only the knowledge which is being coming from the Kubetools.
Yeah, so it's kind of a piece of code. You can actually put it on your website. Hi, can you tell me? Yeah, can you tell me about KRS, what it is? Okay, so can you tell me about what are the new offerings or advancements that are coming in?
So these knowledge bases are getting more fine tuned.
Yeah.
Because first thing is it's gonna run through your whole website, and then we're gonna ask a specific question like prompts to say that okay, this is what is required, and this has to be answered in this way. So we are,
Kind of giving you a demo, like once you sign up on the platform, so there is a way of how you can create an agent and deploy into your mobile phone or into your website or maybe a personalized link, right? So first of all, like we come to the screen where you can actually, oh, this is not the first screen, but yeah, like we do have a couple of predefined templates that you can use, and once we select it, it's gonna pre-populate a couple of information for you, so you can pretty much configure like what kind of voice you want, what language you wanted to have, what welcome message you wanted to put in, the call recording, and a couple of advanced settings as well, right? So next comes customized behavior. So you can actually switch between the customer service, receptionist. We are coming up with a more list, which we are configuring in a backend. So how the agent's gonna work, right? And we can define the goals, a very basic information, the background and instructions, and if you have a business, like do you have a physical location, yes or no? If yes, you're going to give the information to us, the business hours. So pretty much very basic. Next comes to the knowledge base. Here you can actually put in the any question and answers you wanted your bot to work on, and you can come over here and connect your website as well. So pretty much what our backend gonna do, it's gonna scrap or understand whole of all of your crawl onto your website and gonna understand like what's within the website, and going to make meaningful chunks for this AI agent to consume, which is the RAG. And the next, we have a document. So this is capable of pretty much taking the docs, excels, pdfs, any kind of document that you wanted to give with the different chunk methods that is available with us. Integration is something that is coming up so that you can actually connect with the multiple sources, for example S3, Airtable, or any kind of third party applications. So next one is actions. So once you come to the actions, like this is pretty much, you can actually define like what your agent can do. Not only just doing the conversation, answering the questions, but just doing the booking as well, right? So we have a couple of integrations already available, right? So once you connect it, so it's going to populate all of your calendars over here, whether it's a Google, whether it's a cal.com. So once you do that, you can start doing the conversation with the agent, right? So it's going to give you the real-time slots available from the calendar. And once you provide the details that is required to book an appointment, so it's going to book the appointment in a calendar in a real time as well. So you can deploy this into the web. So you just need to copy this code and put it in a head tag, and a couple of customizations. The UI elements you can play around with the voice bot. So you can actually also have deploy it on a phone. So you can come over here. You can find the number. Okay, so country code. Okay, so it's already there. So it's going to show you all of the numbers that are available for you. And we're using Twilio behind the scenes to buy in a number. and automate all the phone conversations. And we are also working on a couple of things, how you can integrate your existing business phone numbers if you already have. So probably you don't want to buy a new one. And when you want to this agent to be available, so probably during always or maybe office hours when your customer service or your staff is not available in the office, so you can actually activate it like after office hours, right? And there is a personalized link as well. So if you have something you wanted to share with a specific group, so you can actually generate a link from here and you can share with your customers. So this is the call logs. I'll jump to I will jump to this agent. So there is a call logs over here. You can see all of the conversation that happened, all of the summary. It's gonna fill up all of the contacts as well. So pretty much that is being developed so far. And if you click on the talk, so it's gonna test this right away over here. Yeah, yeah. This is all about the platform. Okay. Yeah, this is it. I think one slide is left. So basically, the live kit open source, you can actually deploy it on the AWS. So they have a pre-built configuration, the templates, Helm. So you can actually deploy it over there and use the open source version as well if you wanted to go to that much of scalability. But initially, I would recommend to try it with the cloud, which is more simpler and which is very cheaper at the same time. So yeah, that's all I have. Thank you. Any questions? If anyone has any questions.
So guys, you can just try it out on livekit.io. So you can read through the documentations, and if you understand the whole concept of AI agent, very beautifully laid out over here. And in the downside, maybe you can have, if you go to the AI agents, then maybe the deployment and scaling section, you can understand different ways of how you can deploy it. But yeah, just go through it and you can understand it more. So
Yeah, this
is one of this implementation, how you don't want to use a LiveKit cloud, but instead of that, you can use local Kubernetes or any cloud Kubernetes cluster to run this whole infrastructure. So just your SDKs, these live server pod is nothing but the workers, which are just the pods which will be handling your audio and speech to text conversations. So it's just about how you scale your different services over the Kubernetes cluster. This is what is being explained over here. Okay, thank you so much, Vishal. Thank you. I guess we are running short on time, guys. We are very sorry for today. So I'm going to call Baba Sahib. He's a senior machine learning engineer at Shorewise, and his expertise in AI-powered systems, meta-humans. How right now the Vishal has discussed about the speech-to-speech. Now, how you can give a face to a speech. So just like how beautifully you can replicate yourself. So if you are a teacher, if you are a professor, how you can stream yourself to different service, different time zones at the same time, and people can ask questions, people can query you, and the knowledge base is coming out of your knowledge, what you are sharing to the world. So yeah, here you go.
Hi guys. So thanks Vishal and all. Those were all heavy stuff. The backend. This is the fun stuff. So you can see nowadays everyone is working on LLMs, LangChain, right? Haystack, Kubernetes, live kits, everything, right? So what is the next thing? Everything is in the presentation, right? So what if we give a face to the LLMs, to the chatbots? So that is what we are doing. So as Karan mentioned, there are multiple opportunities ahead where you can do education, training, all the opportunities are unlimited, whatever you can think of. So that's what we are. So I work for a company called as Intellion. It's part of a bigger company called as Showas Consulting. It has 1,800 employees. So yeah, there are solutions in the market already available, such as Synthesia, Agent, Revolution, and recently Nvidia also came up with NIM, audio to face. But these are all costly solutions, and I don't think so. Any small company can host it in the company right now. Even you cannot run it on your machine if you want to do it locally. And Hagen and Reillusion, you have to give it a text, then you have to wait for a couple of minutes, then they will send you back a video which you can play it in your video. But if you want to do it in real time, that's a very tough call, right? You cannot do it. That's where we come into picture. We have developed a solution, cost-effective solution, where you can create a avatar of yourself, a digital twin, combined with Vishal's chatbot, live kit, or whatever you want in the backend, and then deploy it anywhere, even in your website, even in your mobile, everything. I'll show you a demo of that. Yeah. So these are some of the avatars what we have. It can be unlimited. Just for the display purpose, we have showed this. I could have shown this a demo, but because of space constraint, I have just image of it. You can see they look a little bit human-like, don't they? Yeah. So, so let me show you a demo of it. Because of security constraint, I can only show it in my laptop. I'll just face it towards you guys. So this is happening in real time.
I'm Nidhi, your virtual assistant from Unity Bank. I can understand and speak in full sentences, so feel free to express yourself freely. Please wait for the mic icon at the bottom before speaking. How may I assist you today?
Hi. Hi. Can you give me my account details, please?
Certainly, Mr. Ponduraj. Your account number is 8020 00000012. It is a seniors account and it was opened on the 31st of March 2021. If you need any more information, feel free to ask.
That's okay. Thank you.
You're welcome, Mr. Ponduraj. Thank you for using Unity Bank.
Yeah.
If you have any more questions in the future,
So imagine you have your own face for your chatbots, and you can have a face for your chatbot. That's what we are doing right now. So yeah, what's stopping us? Nothing is stopping us, but we want to make it more cost effective. That's where we are collaborating with Kubetools to make it more cheaper, you say, and then when you say chatbots, right? It's most of it is text to text. You type in text and then you get a text back in return. But here it includes speech to text. First, you have to convert the speech to text and then the text to speech. So that everything is involved. That's why there will be a little bit delay. That's what we are trying to solve, and that's where we are collaborating with Kubetools to solve this problem. And even you guys are, if you are open, then you can join Kubetools, and then we are working on an open source solution. You can also contribute to it, guys. Yeah. Yeah. Then you can also be an Iron Man when you die. You can also make a video of yourself. Yeah. Thank you.
Any questions?
Yeah. Any questions? I think that was straightforward.
Thank you for sharing your insights on that. Next up, but last but not the least, we have Sandeep Giri, the innovative founder of Turno.ai. Sandeep is revolutionizing how organizations interact with data by leveraging large language models for seamless text to SQL transformations. Today, he'll demonstrate how Turno is making data analysis more accessible and efficient for business users. Please help me in joining Sandeep Gray.
If you send me, you're gonna run the demo over here.
Oh, this I need to keep. This one should be kept here.
You can hold it.
Okay. This is the mic? Okay. I'll just keep it here because. All right. So, yeah. So Metastore and SQL Seal, they are the two parts of it. One is creating a mental clean image of your data. Just like when a data scientist looks at the database, they keeps on making notes for the tables, keep on renaming the table, that this should, the table name should be this, and so on. Without touching your original data, it keeps on creating this image, which is, something very clean. And when it is clean, the LLM can generate the query. And once it has generated the query, SQL Seal makes sure that the query doesn't cross the boundaries. So this is the general flow, the one that I have explained. The consumer connects the database. Consumer asks for the natural language query, and consumer executes the query, and the Turno validates the query and shows results. Now, this is how it looks like right now. You give a question, it generates the query, you can execute it, and then you can export the data, right? So Turno is to database what Docker is to OS. How many of you know what is Docker or containers? Yeah. So I'm assuming that you have come to Kubetools. So, okay. So the way Docker is isolating your process from accessing anything beyond what is allowed, Turno is isolating your original database such that the processes cannot access anything beyond the thing. Now, here is something very interesting. I want everybody to pay attention. This is cool. Are you able to see the font from there? You're able to see? Oh, good. You still are younger than 40 then. Okay. Because I can't see a smaller font. Okay. All right. Now, so one of the coolest thing that has happened after the LLM have come into play is something called chain of thoughts. Chain of thoughts and actions, right? Like, for example, you are a pretty intelligent person, right? But you can't multiply, say, 3-digit number with 3-digit number normally, right? You have to use a calculator, right? Similarly, the LLMs cannot do these kind of operations like mathematical operation or the other things like understanding the entire database. They need actions. Okay, this is where this new whole agentic workflows and all of that comes into play. So instead of you expecting the LLM to do the calculation for you, you provide it a calculator and tell it a problem. It uses the calculator and gives you the answer. So, and that's the breakthrough in the entire thing. This is where it behaves like an operating system. The LLM behaves like an operating system with all these tools to interact with. Like, this is the API to talk to my database to extract the results of the query. This is the API to get my customer data or analytics from here. And this is the API to see the files in this folder. This is the API to start my cluster, and so on and so forth. So you provide these bunch of tools, and then when the need arises, it creates a Python code to call all these tools. And that's the most beautiful thing about the LLM. And this is what people call it, like, we have achieved sort of a AGI because we are able to break down. The second part is called thoughts, chain of thoughts. Chain of thoughts is, I give you a problem, I ask you to come up with the steps, the way I started the discussion. And let's take a look at a simple question here. So the input was, what percentage, that was a query asked by the user. What percentage of trees in Bronx have health status of good? That's the query. Now, to answer this query, what are you going to do? The first thing you're going to do is identify the database and table, right? So it says that I have identified the table. It looked in the folder, checked that there is a file named a modern data.sqlite. The next step is to explore the tables and so on. So this is the thought that LLM came up with when the query was given to it. Now, once that was there, it basically created, right, contains the, right, so it has to find the table. Right. Now, at this point of time, on the second thought, it will go and create a query to figure out the table schema. And then once it has observed the table schema, the next thought it will come up with, the table trees seems to be the most relevant for finding information about trees and their health. I will now explore the schema of trees table. First, it found all the tables, relevant tables. Then, although there was one more step where it tries to find the relevant database. First, it tries to figure out relevant database out of hundreds of databases, and then relevant tables. And then from the tables, it tries to figure out which columns are necessary and then tries to gather all the information. So it gathered this detail, and then trees table contains this. It figured out all these columns are there, and then at this stage, it's going to generate the query. So it generated that query. You see, select, sum, and so on. Based on this thought, it created that query, and then it executed that query, observed its results, and saw that the result seems to look good. So we are done and it's over. If he doesn't get the good results, as in the results are empty or something weird, it notices, it starts again with different table names. And that's a thing, you know. So it did exactly how a data scientist will do. So it broke down the main task into thoughts, a chain of thoughts. And for each chain of thought, it generated the tasks that were needed to be done. And from that, it generated the observation. So the first task, this is a very, very, very interesting part. So first task, that is the input, right? That input, based on that input, it created an observation that these are the tables. From the observation, from the observation, it came up with the thought. From thought, it came up with execution of action. From action, it did observation. From observation, it came up with the thought. From the thought, it came up with action, and that continues. And the great part is, it also comes up with the thought that I should stop, okay? So that it doesn't get into recursion. So here's the thought. It says that this is the final task, I should stop now. So this is the magic that is going to change the way the entire of the information systems work. Now, the beauty of this is this thing is accessible for each and every one of us. And it's all a matter of understanding how do you manipulate the prompt, how do you utilize the prompt engineering in your favor, and how do you utilize the various systems to do really complex solutions to the world. So we have, Toronto has got a big market. There is billions of users. Right now, I'm experimenting with my own database, my CloudX Lab, the company I founded. And we have a lot of data on users. We have a marketing and sales team. Marketing and sales team continuously keeps on querying. And it basically, we keep on doing that. Not only here, there is something that you may notice in Toronto is that in case it figures out that the data cannot be answered using SQL, it will create the machine learning models and it will train that model on the data. And after training that model, it'll give you the predictions. Now, that is the most beautiful part of this era, that all the work that data scientists were doing, that can be done automatically, right? Now, the data scientists, the AI people like me, they have killed their own job for the first time, right? They have eliminated themselves in simple way. But rather than looking at in the negative way, I would say this, that this new era, we have tamed an animal like the way people tamed animals earlier. Now is the time to come up with all kind of mechanics and tools around this animal. Like in horse, when people, tamed horses, there were people who called tamers. There were people who called, right? In India, there in Indian mythology, there is a Ashmeg Yag, means the people who who tame the horses were considered the NVIDIA of that time. Okay, so right, and there's a war. Like if I'm releasing a horse, and if anybody else can catch him, that means that person is capable to challenge me. So similarly now, so there are people who are horse tamers. There are people who are building, building horse carts. People who are doing the horse medicines. People who are doing all sorts of. There's a whole economy around the animal husbandry, right? The whole science. Similarly, now the whole science of AI is now more democratic than ever. Now we have competitions, Gemini and all of that. The price will keep on coming down continuously. Like now Chinese companies would come up with lots of LLMs. So the price that will become like very, very low, which also means that we can build all kinds of solutions without having to worry about the monopoly on LLMs. And of course, the open source LLMs will come in and so on. The only thing that is needed from all our side is that how can we utilize all of this to build a career, build a product, build a tool that solves people's life. And with that thought, I would strongly recommend everybody to understand the chain of thought, chain of actions, and in general, the how you can utilize all these mechanics in your favor. That's my team. This is how the Turno. So those who have used LangChain, they must have seen there's something called SQL chain that does the similar thing, but it doesn't provide security. And Snowflake also doesn't provide that kind of security and accuracy, and so on. So yes, that's pretty much. And any questions? Yes.
For the part about the turnout engine, is there a reason that you chose to write that section yourself rather than using, for example, the built-in sort of user RBAC in Postgres or MySQL?
Yes.
Yeah.
Yes. There's a very good reason. The reason is that the trick here is to do what Docker did. Okay. Instead of relying on the security provided by underlying operating system, they build their own mechanics. And the reason is, number one, if we provide table renaming, table description, or virtualization of the database, virtualization of very thin layer of virtualization, when we provide that, what happens is that, number one, the LLMs become accurate. That is first thing. Second, we are able to enforce the security. So those are the reasons for it. So essentially, the advantages of writing our own system is that we got much more powerful system. Because when I looked at the RBAC-based systems available in every database, so one of the things that is there in databases is called views. So people keep on creating views for each group. As you get more groups of users, you keep on creating more views. And that becomes very annoying. And it is, most of the databases do not let you create a new view. There is a certain only DBAs and certain people who have access to write or modifying the database. And this is why the traditional RBAC was designed for traditional problems. It was not designed for the LLM era. So that's one of the reasons. Yes.
Has Snowflake called you up to acquire you yet?
No, everybody is working on this in a way. So probably Snowflake and Databricks are going to be a couple of competitors, and it'll be good to have those as competitors. So I'm hoping that they will, try to acquire. But my agenda is very simple. It's a web interface. anybody can just sign up quickly without paying a hefty amount to Snowflakes or Databricks or GCP or moving entire data to GCP or AWS. You can just start using in a jiffy. And I'm releasing everything to open source, and so that anybody on the planet can just fork it or just use it, and everybody has access to the same amount of quality tool without buying Snowflake, Databricks, GCP, or anything. So this is the power of new era, and I'm banking a lot on the open source. And yeah, once I release my new stats, so of my accuracy, then it'll be a different game. So I think then the new thing, probably by 1st of January, I'll have a bigger, more aggressive business plan. I am silently building it. I am not talking about it. I'm not approaching the companies right now, and I'm not raising the fund right now. I'm just silently building and experimenting. And I'm pretty happy right now with the accuracy results. They are like the global best is 17%. Mine is 20, and the 3% makes all the differences. Like mine is like 19.45, so I'm not sure. Should I call it 20 or 19? Okay, so yeah, for on the there are lots of databases on the internet on which you can validate the accuracy. So we continuously doing that, and yeah, so I think that's our focus. And any other questions? That was an interesting question.
SQL database or any other database?
Yeah. So what I understood is whether it's MongoDB, for example, or let's say HBase or any other database tools, most of them have come up with a SQL interface, right? Like, for example, MongoDB had this weird aggregations. Have anybody used that aggregation? Like very annoying ones. I'm being very honest with you. Okay, so I think people have come up with SQL translators, right? So I think SQL is much more universal interface. And the other very good part is, so on one hand, well, whether it's Hive, HBase, MongoDB, everybody provide, and even Spark data frames, all of them have started to provide SQL interface, all of them, right? That is the good news for me. And the second thing is LLMs generate SQLs really well. And therefore, it is better to just stick to SQL rather than any other mechanism. So I mean, if I ask it to generate the MongoDB aggregations, it won't give you great results. And I'm trying to avoid it as much as possible, because then like the amount of examples LLM have seen for MongoDB aggregations are not as much as it has seen for the other. So I think sticking to the database for now, the relational database, is something I'm thinking is good. Tomorrow, when it comes to like ETL process, when you have like unstructured data, you want to translate it to the structure. That process, I know that there are many companies who are working on it. So I will basically provide a standard connection to all kinds of databases and let them do it here. And the only thing is that I'll have to build the entire Kubernetes farm now, after we are realizing that the system of actions and the thoughts requires you a big backbone to execute all the actions, right? It's a calculation, it's a prediction ML model, it's a SQL query need to be executed for so many users. So we need to have that now the Kubernetes cluster as a thinking playground for the LLM. So LLM will keep on creating process and coding it, and will work on that code will execute on the cluster and will give the results, and then keep on doing that. So that is something that is happening right now. So yeah, so I think that's a bigger challenge, and that's where I like to spend my energy.
How coupled or dependent your solution is towards the database design? Because I've seen people design database very badly.
Yeah.
Like very weird name to the columns.
Yes.
Is there any, because that's eventually gonna hamper the quality of your results as well.
Yes.
So there must be some layer to actually
Yes.
quantify.
You got it absolutely right. Right.
Is there any way as of
Yeah.
now?
Yeah.
Or is,
I'll tell you my secret. My
what
secret
are the
sauce.
expectations from the database?
My secret sauce is that I assume that the database designs are messed up. Okay. Column names are all weird, right? I have seen, column _1, column _2, column _3, right? And this is the secret sauce for Turno, right? So when you connect your database to Turno, it goes and analyzes each and every table. It looks at the data and infers the column name from the data, and then renames all the column names. And it's not renaming in your original database, it's renaming only in its own image. So it kind of, when you look at your database and you say, is this the database I designed? It looks really nice. Mine was messed up. So that's the beauty of Eterno. So it goes and looks at all the tables, drops all the tables which have no column data, it doesn't have records, for example. And it figures out, it looks at each and every column values. You look at the column and see, oh, this column only contains USD and INR. So the column name should be currency type. And then it just documents it really nice. And then when it is time to generate queries, it consults all of this graph that is prepared and then gives you the answers.
The numbers are like really hard to predict because if it's in the decimal, it can be a weight.
Yes. Yes. This is where a lot of, we call it like cardinality inference. So we try to figure out the cardinality of each of the column. Cardinality means how many unique values are there in this. So if there are no unique values and it's like a decimal number, then it does the analysis like a data scientist would do. Like, for example, if it's a number, it'll say, okay, let me compute the quartile 1 interquartile ranges for the database. Like 20% of the people have this much age, 30% people are within this range, and so on. So it'll basically 25%, 25%, 25%, like that 4 quartile it creates. For the decimal numbers, it basically creates a quartile. And for the normal ones, which has a low cardinality, it creates that. For the string type, if it is lots of strings and they're all unique, then it creates another strategy for querying the table. So those are the few things that are very unique to Turno, even including text search. We are building a text search so that it figures out the keyword in that column. So it kind of indexes and creates its own search on top of your columns. Now, this is something very unique, and I would probably publish it. This is something that has given us the 3% accuracy extra on top of it. Okay. Yeah.
The question escaped me. Sorry. Oh, you're talking about the engine. You want to abstract it because it's true. I was thinking this like the graph databases, like anything you're touching underneath. I think a lot of data scientists are generally aggregating data not just from like one database, maybe multiple databases.
Yeah.
Some of them are aggregating from wherever.
Yeah.
Do you have like a long-term strategy for data aggregation?
Yeah. So the plan is this, that at a single place, you connect all your databases, right? You leave all the databases. The Turno starts at the table level. It goes from table to table, table to table, enhances each column, documents each column, and then goes to a table, documents each table, renames all the tables. Now you have cleaned table names, clean column names, documented tables, and documented columns. And it has a neat established foreign key and primary keys. And then it goes to the database level. And based on all of this, it documents your database. Now it knows that this database contains what kind of data. That database contains what kind of data. Now it has the platter to choose from. When the query comes from this, it has to pick the data from here, 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 here. And so the core idea is to have all the databases connected in Turno, and then it keeps, while you sleep, it studies all your data and comes up with a mental image or what it thinks of the data, and then it keeps on improving it. And you also have a chance to keep on nudging it and say that, okay, this is a wrongly annotated table, so can we keep it this way? And then it basically takes it from there. So yeah. So now that's a secret that I foresaw last year when I was in December, that this is something that is going to be the thought in 2025. It'll become a common sense by the end of next year. And right now, people are starting in that direction. So it looks very weird. Everybody has a question that what's the point of building a security layer or an image on top of your existing databases? But that'll become a common sense. What Toronto is doing right now, it'll take 1 year to become a common sense. And like this year, I saw Snowflake and a couple of researchers from Snowflake coming up with a similar product. And at the same day when we had the talk, right? That same day, I saw them. Okay, so people now, this will become like a common sense. So I think this is much more needed, so to speak. And and I think this will actually improve the organizational productivity in general. Right now, there's just too much of back and forth of querying. And I remember I had worked with some of the, like, for example, this company, the Data Valley, there are 4 engineers, they're based out of Montreal. So there are 4 engineers dedicated to just writing queries and doing the same thing over and over. And it's just not worth the time of people. Okay. And on top of it, a bigger trouble is when, let's say, you as a business leader, you want a simple query, simple analytics, right? And that analytics is taking 15 days, which essentially means that you won't execute at a fast pace. In the end, you will miss the bus. Okay, and that's a reality. And therefore, the LLMs will solve that problem. That you gave the task, maybe it took like 10 minutes, or maybe it took like 2 minutes, somewhere between 2 to 10 minutes, it'll give you the answer. If it is training a model, it might take half an hour, or it might take a day, okay, but it'll give you the good results. Now, 1 day versus 1 year is a big difference, okay? Sometimes the machine learning projects which I've seen in industry, that same kind of thing that can be done in a day by a machine takes probably maybe a quarter, because you have to talk to all kinds of stakeholders, you have to explain them the problem, what you are trying to do, then they will talk to the database expert, then they'll be hunt for where is my data, and then the entire thing will take forever. And I've seen this in my experience, that something that can be done by machine in a day took a quarter for a team of 5 engineers. And that's a reality. So it's something that Toronto will solve. All right. Thank you, everyone, for a wonderful set of questions.
Thank you, Sandeep, for going through such a different topic and not very well spoken or discussed in general. And hopefully we'll get some benchmarking numbers and some more performance above 20%. And
maybe you should publish a paper before somebody.
Absolutely. So it's a fight against the big names.
If you can publish a product, publishing a paper would be secondary.
Yeah.
So if I couldn't publish a product, I would probably publish a paper.
So I guess yes. So here we are right now, and this is the end of this session, guys. So let's have a quick picture together, and let's mark it up, and we'll see you soon in the next one when we plan it. Thank you all for coming.
And thank you, Karan. I forgot to say.